to do recording and then share screen. Oh, anyone, before I start to share my screen, you remember last class I left some questions. I remember, Alex, is it you said you got some ideas? Do you want to start first to share your thoughts about the question I left?
I would prefer if you could show the code, and by your code I could explain.
Oh, okay, then let me share screen, okay?
Sorry.
Hold on, let me get to my code here, yeah. Where is my Zoom? Oh, it's just, hold on, okay, let me find my Zoom first. Then I need, how do I get, probably I need to stop sharing, okay, first. I need to get someone here. Okay, he got in, then I'm going to go back and share my screen. Okay, I started share screen. So let's go over the question a little bit first. So you remember we have last class we discussed the example, is it? We have two class, data class and data class defined in data class defined in data package, and the employee class defined in employee package, is it? And then have a driver in its own package, is it? And in our data class is pretty simple, just month, day, and year, is it? And initially, our initial data class, before I add this is later on I add. Before I add, the data class is an immutable class because there is no set method, is it? Now I add this set month method, is it? And I just assign the parameter to the month instance variable. Okay, then let's get back to employee class. Okay, our employee class initially, did I say, let's first quick review. Okay, the employee class, we have first name, last name, instance variable, its type, it's a string, is it? And we also have birthday and high date. And the type is the date class that we just defined, is it? And then over here, we add the get birth date, because initially this part, not in the employee class. Initially, employee class is also just an immutable class, is it? Because we don't have any mutator, okay? And now over here, I add a method called get birth date, and I return this birth date. Okay, so that's regarding this part. And then let's go back to the main. Okay, in our main, what we did this part is before we add that set method for a data class, is that we have an employee called Susan Bake, is it? And then I change this birth month to a new one, is it? So my question is does this going to have some impact to Susan Bake? Will this have some?
I said that it's going to have impact, and why? Because the object birth is a part of the object employee.
Yeah.
So they are both connected. So if you change the birth, the employee will change too, because they're connected.
Yeah. Okay. So if we draw the diagram, is it stack memory? and heap memory, is it? And we have E1 here, is it? And the E1 is Susan Bake. Susan, is it? And Susan, it has its birth date. So I just write as B, is it? And the hire date, is it? And both of these two point to date objects. These are the two data objects. And then you said, I said to initially the birth date is month is July, is it? This is 7, is it? And then so this is the birth. Then you set its month to -100. Oh, for some reason. You set it to -100, is it? So if you take a look, because what? Because over here, is it? You changed it. You changed this birth object, is it? That's why you also change Susan's birth date, is it? So the question is, can Susan's birth date be a -100 months? Definitely, you cannot do that, is it? You cannot do that. Okay, so this is not a good design, is it? There is a hole in this design, is it? There is a hole in this design. So then let's go back to the employee. Okay. So my other question is this a good design?
No.
Is there any problem? No? Yeah, very good. Why no?
Well, we need to put some restrictions, like that there are only 12 months and 30 days, 31 actually.
Okay, we don't need to worry about this. Let's get back here. Let's go back to my data class. Data class, you remember initially when we, assuming I comment out, I don't have this method now. Suppose I don't have this. Okay, I don't have this. And I don't have this. And then whenever you set a date, is it, we already do the check. You remember the month value should be legitimate here, is it? We already set the check here. Okay, and then let's go back to the employee. So if I comment out that, so is this still a good design? Because the birth date should be always legitimate value. There shouldn't be any problem with the value, is it? Is this good design? And let's go back to OOP. So OOP, so far, the feature we learned, the major feature is about what? Who still remember that fancy word? OOP.
Encapsulation?
Yeah, encapsulation.
Oh, well, I actually realized what's the problem. We have a class employee, but we use in this class public date. We don't use public employee.
Yeah.
Why?
Yeah, so let's go back then. Yeah, you got it, yeah. So you see, the birth date is what? Is private. Why we set it private? Because we don't want external world to get to it. Is it? You don't want to expose it. Is it? You want to hide it. Hide it. But then over here, you say get birth date. You return it. Is it? You return it, you expose it. Because this method is public. Is it? So there is problem. Is it? Between the OOP's encapsulation. Is it? Versus this public. So it violates the rule. Is it? Violates the rule. And violates the rule. Let's go back here. If I don't have this set months, it's still okay. It's because it's an immutable class. Anyway, you get that data, but you cannot do anything. Is it? But just like I showed, if I have this set method, if the class is a mutable class, is a mutable class, is it? Then you expose this, is it? You expose it to public, is it? And then over here, basically, even if I don't have birth, is it? I can still do something like this. Date, stolen date, is it? Equals to what? Equals to E1 dot. Then I can call the get birth date to get the birth date. Is it? Get the birth date. Okay, then my question here I change. Stolen. Then I can do something like this. Is it? So will this change Susan's birth date? Will this impact Susan? The stolen date? Anyone knows the answer?
No, because it's a different object.
No, it won't. Your answer is no. Okay, so let's draw the diagram. So we have the stack E1. We have the heap. Is it? We have Susan here. Is it? And it's a birth date and a hire date. Okay, I just write as B and H. Okay, so this is birth date. Birth date is July 25 something. Is it? I don't have enough space. The hire date is January 15 something. Is it? Okay, so E1 dot get birth date will return what? So based on your ideas, it's going to return. So in this diagram, you mean it's going to return a new date?
No, I just realized that it's gonna change.
It's not going to return this, is it? Because there is no place you see new, is it? The only place you see new is here, is it? We only have this two new date. So then in my diagram, which one is going to return? So the stolen date, where it points to on this diagram. So stolen, where stolen date should I put? On stack or on heap? The stolen date, this variable, where should I put? On the left box, on the right box?
On the left box?
Yeah. It should be the left stolen date. Then the stolen date, where it points to. It's not a primitive data. That it is an object. So where it point to?
To July 25.
Yeah, to July 25. Is it? And initially, the July 25 is supposed to be hidden. Is it? At least over here, you will say, okay, it's open because here you create. Is it? But you don't know it's Susan's. But over here, through this get, you know it's Susan's. This object belongs to Susan's. Is it? Initially, you only know that, oh, that's a floating object there. But you don't know who the owner is it? But through this get method, then you know the owner is, because assuming you're an attacker, is it? You're attacker, you target the owner's property, is it? Then you know, oh, that's the owner's property. Now I can attack. Otherwise, it's floating there. You don't know its owner. If it says, I'm anonymous, you won't attack, is it? But it says, okay, it's Susan. You target Susan. You want to defame Susan, is it? Then you can do something like this, is it? So you can, through this, because your design has a hole, then okay, I can get it. I can do some malicious thing. Is it set it to a non-existing thing? Non-existing thing, if in a system, it's going to broken. The whole thing is going to be broken, is it? So there is a problem, is it? So we need to be careful here, okay? So this is regarding secure design, okay, secure design. And so here the concept is, this is a class, is it? If a class instance variable or class variable, okay, similar, is not primitive type, or immutable type. Okay, or we just say it's some object. If it is some object, is it? Then if you provide the accessors need to be careful. Okay, this is not desired. Okay, because then you can change. But you may say, I just wanted to know what the value is for the birth date. Okay, and then you cannot change it. Then the best way is you can make a copy of this birth date. Okay, so then in this case, what you can do is you can do new date. Okay, new date. And then the birth date. But it needs to provide the corresponding method, okay, like the get day method and get month method and get year method, okay, to create a new date. If I change it to return this new and with exact the same value of the birth date, okay, birth date. And then let's go back here.
So I have a question.
Yeah, please.
So we are not allowed to provide, like it's not good to provide accessors to variables, right?
You are allowed, but here it's what kind of information you need to return. Not to recommend directly return the instance variable itself. Okay, so yeah, very good question.
Like it's not good to return instance variables, right?
Yeah. If the instance variable is the object type. Okay, so if instance variable is mutable, mutable type object. Then not, so this is a secure coding recommendation, okay? Not to recommend to return it. Okay. So
it will be fine if we will return first name or last name at this point.
You return first name, last name, perfectly fine, because string is immutable. You cannot change it. You cannot change the object. Okay, so in this case, then we recommend to return the clone. Okay, not to the object itself. Okay, you return a copy. So just like what I say, you can return new date. And you create a new date, you return it, okay? And then let's go back. If I don't return birth, return copy, is it return copy? And then over here, I said get birth date. Then what's going to happen? So here's that E1, is it? And here is that stolen date. Is it? Here is Susan. Susan, is it? Then it has its birth date. This is the birth date. This is the higher date. Is it? So now after I change the get birth date, the implementation, where the stolen is going to be, who is going to be the stolen in my diagram? So it's going to be 725 something, is it? So what's going to happen? Then it's what? Because you call new, whenever you call new, what's happen? That's called a new date. Is it new date? Then it has 725 and 1950. Is it? It copy. So those three values are copied from Susan's birth date. Is it Susan's birth date? And the stolen on what? On that guy. Is it? And you change it to -100. Will Susan be impacted? No. Is it? So if you want to protect your design, is it your class, your object? But you also said, oh, I'm also interested in getting to know some detail about the information. Then you can provide this way. You create a copy that we call this a clone. Later on, we will also learn the clone method, okay? So you create a clone, is it? And then it won't impact. That makes sense?
Yes.
Okay, so this is regarding secured design, okay? Because the whole point here is about OOP, it's encapsulation. Is it encapsulation through the private? Is it? But in Java, we see the private can be broken when you provide accessors. Is it? So to avoid that, then that's the way we do. You provide for the accessor in certain circumstances, then you need to provide a copy of that object, not the object itself. Okay, so that's the idea. Any other questions regarding this part? Everything is clear? And then we already finished this example, is it? Yeah. So nothing new in this example. So that's the major point I want you to think about it. Okay. And so after class, you can think about date and employee class have accessor and mutator. You can just think about it. What's the best design? Okay, and then you can try like what I did. Okay, and then let's go to the last part of our class. String class is it we just learned. String class is immutable class. Okay, that means you cannot change it. Okay, you cannot change it. String is immutable. Okay, so basically there is no set method in string. Okay, it only have accessors. And today we will learn some other thing. We call it a wrapper class. Okay, wrapper class. So in basically in a lot of programming languages that we have the differentiation of primitive data type. Okay, primitive data, sometimes like in Python, you may call it a scalar or something, is it? And primitive data type is like what? Is like integer, is it? Float, char. Is it? They are primitive data type. Okay. And we also learn object or reference data type. Is it? So it's some kind of class. Is it some kind of class? We learned the string. Is it scanner? Scanner, is it our time class? Is it date class? Employee class? Is it? And what? Scanner. Oh, we also learn like the pointer to D. Is it all of those belongs to object data type? Is it? And in Java library, there is some other class, wrapper class. So corresponding to primitive integer, we also have a class called integer. Yeah, so we also have integer class, okay? And for char, you also have character class. Okay, and those kind of class, we call them wrapper class. Okay, a wrapper class like integer, char, they are immutable. Okay, immutable. So their functionality is to what? To convert a primitive data type to objects. Okay, to object, because sometimes we need to modify arguments. Okay, and for primitive, definitely you cannot do that, is it? And also it says because in Java utility package, that utility package, it only handles objects. It cannot handle integer or character. Okay, these are okay. It can only handle. That's why. And later on, we will also learn Java collection framework, okay, regarding all sorts of data structures, okay. And over there, they only take objects. They will not take a primitive type. Okay, primitive type. And a lot of time in Java, especially nowadays, is it we need to do multi-processing, is it multi-threading, is it? And for primitive, you cannot do synchronization, but for object, then you can do synchronization. So those are the purpose that we need wrapper class, okay? So that's the general idea about wrapper class. Then let's take a look. So over here, we are going to use the big integer. Okay, we call it big. And the packages from called Java language package, java.lang package. Okay, and the class is called integer. Okay, then let's see, how do we use it? Okay. Okay, so here, let's see. This, generally, so far we know this, is that if you do integer I equals 100, Nothing new, you just assign 100 to I, is it? And this happens on what? Only on stack. Stack I, is it 100 assigned to it, okay? And over here, there's a different story. You do integer x. This x, the type is this big integer, okay? So this x is an object of integer. Okay, integer. And then it does integer and parentheses. Okay, now I have a question for you. And what do we call this? Integer parentheses and then with 100. What do we call this? New, then integer, then 100. What do we call that? What does that integer parentheses mean? So what does this mean? Integer parentheses with something. What does this mean?
Like we assign a value to an instance variable in integer object.
Yeah, and we have a name for this. What do we call it? There is a name for this? Oh, okay. What is this? If you saw something dot, something and the parentheses.
Method.
Yeah, this is called method. And then what do we call this? We have a
Method.
special name for it.
Constructors.
Yeah, it's a constructor, is it? Yeah. So basically, this is integer class, is it? In that Java.language, is it? So basically, that's a Java folder and then language folder, is it? And within it, you have that integer.java file. Is it? You have that integer dot, and that integer Java file looks like what? It's a public class integer. Is it? And we don't know what its private instance is it? But it does have what? Have something looks like this. Public, is it? Integer, and with some integer value. Is it? Something looks like that. Is it? That's a constructor. Is it? This is a constructor, okay? So we know this. Is it? It's a constructor. So this use primitive 100 value to create an instance object of integer. Is it? And so what does this look like in memory? So this is a heap. Is it? And here is a stack. So X, is it? So here is that 100. Is it? Point to here. Is it? Okay, and you can also do something like this. You don't need always to do this. You can just directly do integer X equals 100. Regular, you may see this is not working, is it? This is a primitive type. The right side, is it right hand? This is left hand. The type doesn't match, is it? Generally, when you do assignment statement, the type should match. Is it? You cannot assign a type X to A. That's not allowed. The type should match. But this is okay in this special case, okay? This is called auto boxing. So it automatically know it does this. It's just a shorthand of new integer 100, okay? We call this auto boxing, okay? Perfectly fine. Just like string, you can also add equals hello. Is it? You never need to do, suppose you need to do new string. Hello, is it? But you don't need that, is it? So this is called auto boxing. Okay, so perfectly fine. So either way you can do this. Okay, and then within this integer class, is it? You can call int value. So this method returns a primitive value. Okay, returns whatever the primitive instance variable's value is. Okay, so this method is what? Is instance method. Is it of this integer class? Okay, integer class. And then let's see, next one. Here I have an x2, it's integer. What it does, it's something looks like this. Is it? It has a value of method. Is it? And within it, you pass with what? It's a string. Is it a string? So what this method does is convert the string. Convert a string to what? To integer. So the return type is an integer. Is this an instance method or a class method? Value of. Value of.
Class
Who knows?
method.
What?
It's a class method?
Yeah, the value of is a class method, okay? So it's not an instance method. And then you can also do this, pass int. What it return primitive value, okay? And it converts string version, okay? It's what? It's also a class method of integer, okay, integer. And over here, I also call this function, I call modify big I. Is it? Let's see what that method looks like. So this is modify I, the parameter is I. Is it? And I do something like this. What is this? Will this change I? No. Is it? Because I is what? I is immutable, okay? You cannot change it. And here there is another interesting question, okay? Let's see. Clear. Initially what? Initially it's called X. Is it? Okay, X is 100. Okay, very good here. So here's some brain teasing. Let's see. We have stack X. Is it? And then here we have that big heap. Is it? And we have that 100. Is it auto boxing? And or the new int? Is it with new integer 100? Is it? And it to create this 100 object as a x pointer to here. Is it? And then I call modify I. I pass in x. Is it? I pass in x. So I, is it? I is what? I point to here. Is it? I point to here, 100. And then over here, I do I equals negative 100. So where negative 100 changes this 100 box, where does that negative 100 happens? This is very interesting. Okay. Very interesting question. Think about it. where the negative 100 is going to locate. Anyone knows the answer? Okay, then let me just leave this as a question, okay? Then who can find the answer tomorrow, let me know, okay? Suppose what over here, I'm going to do something. I'm going to do a loop for integer I from 0, I less than 1,000,000. Something like this, okay, then I plus plus. Then I do something like this. Okay, then just think about it. Okay, think about the stack and the heap. And then let me know. So here is that x 100. Is it? And I is here. Okay, then I have a big loop. Big loop. The loop keep assigning negative 100 to I. Okay, so just think about it, go home. Okay, so what's going to happen on heap, on stack, where the negative 100 is going to be, everything, okay? Okay.